Before I start setting up the filtration, I will take my leftover ethanol that was taken off the hot plate. It's room temperature now, it's just sitting out. And I'm gonna cool it down in an ice water bath. So I want to put it in a beaker, sorry, I do want to put it in a beaker that's just big enough to fit the flask, but won't allow it to fall over, so it can't fall over. I do not want to do this. This is a common mistake students make. They set their flask in the bucket of ice and leave it there, and then they go to the bathroom and they get a phone call and they're distracted. The ice melts a bit, this pours out and it's gone. So we don't want to do that. We always want to use a beaker that is just large enough to fit your Erlenmeyer with some ice. And when you want to do this, if you use just straight ice, it'll work. This will cool your beaker, and there's no way it'll fall over. But if you wanted to do it quicker and better, you should add a little bit of water, because ice water will coat the outside of the Erlenmeyer flask more fully than just crystal ice, and then you'll get more surface contact with the 0 degrees Celsius water and more cooling. It'll be quicker to cool. For instance, if I put my finger in this ice water, it's colder than if I just put my finger in the bucket of ice, because there's more contact with my finger. Okay, there we go. So I'll put this ethanol Erlenmeyer in there, just roll it around, let it cool. So it's going to be nice and cold by the time I have my vacuum filtration set up. Oh, you know what? I forgot to mention earlier. I had a beaker over my crystallization to slow the evaporation, but when I thought about it, I thought, oh, I want to see the crystal growth nice and slow. So I removed that beaker and I videoed with the beaker off. And the beaker is not like something you have to do. It just slows down the crystallization a little bit more, but I felt I'd rather get a good video than worry about it. And it worked out. It was a good gamble because these crystals look really good. I like those needle-like crystals. They look nice. This is going to be much more pure than the original sulfanilamide. Okay, so I'm going to set this out of the way for a second, and I'm going to start setting up my vacuum filtration. So I'm going to create a vacuum with my water aspirator. What this is, it's a water tap that has this aspirator right here attached to the bottom of the water trap. And then underneath, when the water comes out, this is just a homemade, what we call splash guard. It helps with water splashing up on the counter. So let me show you how that works. I'm going to take off the splash guard, because a lot of times, well, if you're in lab, you might not have your splash guard on, and there's your end of your water. So here, my nozzle is behind me, so let's turn on the water here. Turn on slow initially. So see how the water's slowly coming out of the bottom? To get a good vacuum, I need to turn the water up higher and higher and higher. And after a while, it starts splashing out on me. So I don't want that. So we just take this pasture pipette bulb and we poke some holes in it and put a wood dowel through there and a pipette through it, whatever we got, to slow down the splashing. So now with that on there, the splash guard, I should be able to turn the water on full blast, and it's not splashing on the counter. And what's happening is the water, as it comes down the aspirator, it's causing a vacuum right here. It's sucking on my finger. Okay, so, and I'm going to hook up a vacuum hose to that. Now to add my hose to the aspirator, I just push it on the end there. And this hose it's not actually technically a vacuum hose. It's got pretty solid walls, but the vacuum that we're going to be pulling, it'll be fine. It might collapse a little bit, but it'll still provide good suction. Okay, so now I'm going to turn my aspirator on again, full blast, and I'm going to see how much suction I get at the end of the hose to make sure the hose doesn't have any leaks. So I'll turn that full blast to get in the water. I'll come on over, put my thumb there, and yep, it's holding my thumb good. Looks good. Next, I'm going to add the hose from the aspirator to my water trap bottle. It's best to put this on the longer glass rod in there. These are about the same height. They're both pretty long, short. But the one that's deeper in, I'm gonna hook that up to my water aspirator. When I initially try to hook this up, it's gonna be way too loose. Look at that, that's not gonna work, that's too loose. So what I'm gonna do is I'm gonna put some parafilm around this to make it thicker so I can get a good seal on there. I'll show you how to do that. Also, this bottle is notorious for just falling over, especially when hoses are attached to it, and it's glass, it can break easy. So I always want to be good about this and take a moment to not just use it without it being clamped down. I want to clamp it down. So I got this ring stand here, and I will get an extension clamp and I'll clamp it to it. Let me go grab one of those. I grabbed an extension clamp and I've added it to my ring stand, and I'm going to hold this water trap bottle with that. But before I attach it, I think it'll be easier to first use the parafilm to make that glass tube a little thicker on the end, so we got a good seal with the hose. So the way I'll do that is I'll just take some of this parafilm and cut it off with a nice size piece here. Parafilms like our laboratory saran wrap or Glad press and seal, whichever of those you use. That's what this is. So I'll show you how it works. It's pretty cool. It's real stretchy. I'll set my phone down. Hopefully you can get a good view of this. So you have to first take the paper backing off of it. See, I usually just tear it a little bit, peel off the backing. And this is the parafilm. It's hard to see, huh? It's kind of clear. I'm gonna fold it in half. Maybe I'm gonna fold it twice in this case. And then I'm gonna stretch it out and wrap it around the glass tubes off of my water trap bottles. Okay, here we go. I'm gonna take my parafilm and I'm gonna hold it onto the glass rod with one hand, so I'm holding it down tightly. And then I'm gonna stretch it out. It stretches easily. And then when you stretch it, it becomes tacky. So then you can start wrapping it around. And as I wrap it around, I'll occasionally stretch it a little more. And then I've got to just kind of eyeball it and try to see when I feel like it's going to fit well now with my other hosing. It's getting there. I'm going to go a little bit more. Stretch and wrap, stretch and wrap. And I think that's going to be enough. I'm going to go actually, when you keep stretching, it just breaks. So now I can just hold that there and let's see how it works. Put my hose over. Yep, feels nice and snug now. All right, so if I have no leak here, here, and the rest of the places, I should get vacuum at this point. Or actually, I can step it back. I can even look inside of here first. Let's see if I can get my cap off. So I can check that I have vacuum here. So why don't we turn the water aspirator on full blast again. Yep, I can feel my finger sucking to it. And now when I put it back on the water trap bottle, I can check that I'm pulling a vacuum this way, right? And so the flask should be under vacuum if I close off this other end. Yep. It's a little bit weaker, but no, it's all right. I feel it. And now I'm gonna put some more parafilm on this end for its hose, because I'm thinking of using this black hose here. It feels a little loose. This is more of a vacuum hose here. It's a little stiffer, but the other one will work fine too. This little leftover piece of parafilm that I pulled off the other side might be just right for this smaller hose. Let's stretch and put it on. Stretch and put it on. There we go, almost. Okay, I got it. So let's try it. Yeah, that feels pretty good. I feel like it's going to be nice and snug. Be careful with this. The glass. This is a glass piece of tubing, and it can break. So you don't want to go too strong on it. Okay, so now this guy now is very top heavy. Before I test the vacuum on this end of it, of this hose, I'm gonna clamp it now, like I was saying before. So I'm gonna bring over my ring stand with my extension clamp, and I will open it wider. Oops, wrong way. Okay, let's see, Is that gonna work? A little bit more. Okay, that should work. And then I'm gonna lower this down a little bit. Okay, I think this is gonna hold it well. Tighten it up. All right, I think we're good. Maybe a little more. There we go. Oh, no, it's not there. Now I think we're good. Okay, so now I feel like my water trap bottle will not fall over. It is looking good to me. Let me show you on the side view. Yeah, it's looking good. So I've got my water aspirator with its tube coming off of it to the water trap bottle, and it's attached to the longer glass tube in there, slightly longer, and then the other hose is coming off. So let's check this hose. We should get good suction at this end when the water aspirator is on full blast. So let me do that. You know, it feels kind of weak. Okay. I want it stronger though. I have a feeling I've got a little bit of leakage here. Let me see if I can fix that. I'm gonna try wrapping a little bit of parafilm around this part. I've shimmied this up out of the 2-hole cork, and I'm gonna wrap some parafilm around this and then push it back in hopes that it'll seal off better in there. This kind of setting up of your water trap bottle usually happens like once at the beginning of the semester, and then you can use it all semester. So it's good to see the first time. Now I'm pushing it back down in, and I'm gonna see if that helps. Feels a little better there. A little bit. I'm gonna try this side now too. I'm gonna rise this up a little bit. Wrap some parafilm around this. Sometimes this sort of situation is remedied with a new rubber stopper. This rubber stopper might be getting a little old and brittle, but hey, let's see if we can fix it. Let's learn how to be, smart and be problem solvers, not just always buy the new thing. Let's see. I think this actually, yeah, got better. Pretty good. Okay, so now the next thing we'll hook up is the filter flask. Here's our filter flask. I'm going to use this 250 milliliter filter flask. Filter flask has it's an Erlenmeyer flask with a sidearm on it. And I'll hook up my hose to the sidearm, like so. This one fits on good. I don't need to add any parafilm. I could have just bought hose that fits all my parts perfectly, but then, you wouldn't learn how to deal with issues. You wouldn't have the eye of the tiger in lab. If everything's perfect in lab, you don't get as much results. Okay, I got another extension clamp on another ring stand here. And I'm gonna lower it down and grab onto my filter flask. So, slide this down. Lower. I'm twisting these here to make it close. It's looking good. And now this is nice and secure. Okay, I like it. It's all set up well. Oh, let me flip this video over. Okay, so I've got my filter flask clamped to my water trap bottle, and then my aspirator. So let's turn the aspirator on full blast, and let's see if we can get a vacuum to build up in here. Put my hand over it. Yep, I feel the suction. Listen for it when I let go of it. You hear that? Got good suction. All right, now let's do something fun. If we put parafilm over this, you can see what happens. What I'm gonna do is I'm gonna take some parafilm And I'm gonna cover this up and then turn the aspirator on full blast and see what happens. First, let me put the parafilm on. So I'll take the parafilm and I just tear a little bit of the side so I can get that, someone to grab that paper, see how it's, paper's ready to come off. Take that off. I'm gonna fold it in half, make it a little bit stronger. And then parafilm, like I said, it gets stretchy. When you stretch it, it gets kind of tacky. That's how I'm stretching it. So I could stretch it and put it on here to make it really grab onto the opening of the filter flask. Okay, I think it's on there pretty good. Now what I'll do to let you see what happens better, I'm gonna make turn the video to slow-mo. Pretty fun, right? Yeah, this is gonna get us a good vacuum. So one last thing we can check is our Buchner funnel. So I've got my Buchner funnel here. It comes apart. It's just a funnel with a stopper. So that goes there, and then you put the top part there. It's got the little holes so the mother liquor can go through with impurities. So I can put my palm over this. My palm will cause a seal, and I can see if I get suction on my palm. And if I do, then we're all set to go. So let's try it. Turn the water on. Yep, I'm getting good suction. All right, everything looks good. Now, right now there's no vacuum because of these little holes, but there could be a slide vacuum. It's best to always break your vacuum like this before you turn off the water aspirator. So what happens if I have a really strong vacuum and I go and turn the aspirator water off? I'll show you. I'm going to hold my hand over this to get the best vacuum, and I'm going to turn the water aspirator on high. Then I'm going to turn the water aspirator back off, and you'll watch what happens. So first I'll turn the water on. Full blast, right? Okay, I'll hold my hand on this. I can feel the suction, so there's a vacuum within this filter flask. And I'm gonna set the phone down and turn off the water, and then I'll pick the phone up quickly to show you what happens. See what's happening? Look. It's sucking water into the water trap bottle. Well, it's trying to. Didn't quite do it. It got slightly up the tube. Let me show you again. Okay, this time I will keep, I have to have a videographer probably if I had to do this properly. But I'm gonna keep the camera on the hose coming from the water aspirator. Let's see if you can see the water being sucked back in there. So turn the water on full blast. It's actually, there was some water from last time. It's being sucked into the aspirator. Okay, so let's watch carefully. I'm gonna put my hand over the filter flask to cause the vacuum to build up in the filter flask and also inside of the water trap bottle. And now while there's a vacuum in both the filter flask and the water trap bottle, I'll turn off the aspirator. And see, oh, it sucked water in here, huh? It actually sucked some into the water trap bottle too. Some dripped into there. So the water trap bottle did its job. If the water trap bottle wasn't here, this water that's trying to suck its way up, instead of going into the water trap bottle, it could have went into my filter flask. And I don't want it in there because my filter flask has my mother liquor, that's ethanol, and I might want to take a second crop of that ethanol mother liquor. I don't want tap water in there. So that's the purpose of the water trap bottle. But even though we have the water trap bottle for that purpose, we still don't want this to happen. So under normal circumstances, you want to always, if you have your filter flask, if you have your Buchner funnel on top, remove it, break the vacuum, so air can suck all the way through, then turn off your water aspirator. So I think I have a little sign up in lab here. So always break. Where is it? Am I blind? Oh yeah, there it is. Break vacuum before turning off aspirator. So you always want to like open up the vacuum system, then turn off the water flow. My Buchner funnel has these holes in it to let the mother liquor and impurities through, and they're pretty big relative to the molecule size, so I might lose crystals through that, and I want to get my crystals back out of this when I'm done filtering, so I'm going to use filter paper. So I'll go over to our box of filter paper. I got this one, which is like this micro glass one. When I put it on, oh, it just barely covers up the holes. I don't want to risk it. It seems a little too small. Then I got this one. Oh, it's about the same size. Not looking good. Then I got this big daddy here. Ugh. But what I'll do, I'll cut out a circle of this. I'll trace out a circle, and I'll cut it out to make it fit, since I don't have the exact size for this. When you do this, you might think, oh, just grab your pen and circle it and cut it. It's actually not a good idea. Instead, you want to use pencil. The reason why is the graphite in pencil doesn't dissolve much in organics, but the ink in pens does. So we don't want to introduce ink impurities. We want to use pencil. So I'm going to grab a pencil and do this. All right, trace out a circle on this with pencil, and then cut it out with some scissors, some skizzers. There we go. Let's see how good are my cutting skills. I think I can cut it a little bit inside of the pencil line would be best. If for some reason I was doing it with pen, which I shouldn't, I'd make sure I cut within the pen lines. I don't want penning on this. It's interesting how in an organic lab, pencil is more permanent than pen, because pen ink is so soluble in organic solvents where pencil ink isn't. So like if you had a notebook filled with pen notes and you spilled acetone or diethyl ether, hexanes, they would dissolve the ink away from your paper pretty good or smear it, but then pencil won't. Okay, got my circle. Let's see how it fits. It might be a little bit too big still, but that's okay. It's kind of a preference. Sometimes I like to have it a little bigger, so I just kind of push it into the edges. So now I feel like, yeah, there's no way any of those crystals are going to slip past and then go into the mother liquor. I feel like that's pretty good. Now I'll take my bottom of my Buchner funnel and I'll attach it to the top of my filter flask, and we're about ready to go. Let's filter these crystals. They've been patiently waiting over here. Normally I would have had this all set up while this was crystallizing, but my camera was busy filming the crystallization. That's okay, it makes for better video. All right, so as I was setting this up, my ice beaker melted pretty good. That was cooling the ethanol, but luckily I picked a good sized beaker. It hasn't gotten water into it. It's a little bit close actually. It's not too bad though. Let me pour some of this out to be safe. There we go. So now, yep, there we go. And to start this off, what I want to do is I'm going to first wet the filter paper with vacuum to suck the filter paper down so that it's harder for crystals to get around the filter paper. Then when I get my crystals into this, I don't want to be too gentle about it. I got to break them up a bit, and I got to swirl them and dump them kind of fast, because otherwise, if I just pour slowly, the mother liquor pours out, but the crystals stay behind. So let me demonstrate that to you. First, I'll turn the water aspirator on full blast. And then I'll pipette some of the cold ethanol, get onto the filter paper, get it all wet, and have it start sucking down. Okay, now my crystals, I'm going to kind of jiggle them and see if they break up. Yeah, they broke up a little bit. See that? And now when I want to pour them in, I got to I like to kind of move, dump, and tap the bottom. Try to get them all out as much as possible. I did a pretty good job. I have a little bit of crystals in there, not too many left. And now I have a decision to make. Is this loss acceptable? or do I want to try to wash them out with cold ethanol? I'm going to try washing them out with cold ethanol. I'll just put a little bit in initially, and then I'm going to look at it and decide if I want to pour this on the filter paper. I think I do. It doesn't look like much of those crystals has dissolved yet. They're still there, so I'm going to give them swirl, 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 dump. Once again, I got a decision to make. I got some crystals in here. Do I want to put ethanol into this and wash it in? I think I'm not going to. I think I got enough out. If I put more ethanol into this and poured it onto this, every time I pour ethanol into here and onto there, I'm dissolving the crystals I already have on the filter paper. So I don't want to do too much of that. And I will do one rinse of these with the cold ethanol, these crystals that are in here. I'm going to do one rinse. As I'm doing this, I'm watching, and if I see the crystals are dissolving too quickly, I'll stop. But I do want to wash the mother liquor off these crystals a little bit. This way they will be more pure. If I didn't wash this with clean ethanol, then the mother liquor that was coating the outside of the crystals would eventually evaporate, and all the impurities dissolved in the mother liquor would show up on the outside of my nice pure crystals. But if I decide, oh, I want to make sure to wash off all the mother liquor, and I just keep adding more cold ethanol, every time I add cold ethanol, I'm lowering my yield because I'm dissolving away my crystals. So I think that was a pretty good amount of wash. I think you're going to see later we have lots of crystals in here still. And there is the mother liquor down here with our impurities and some sulfanilamide as well. You always lose a little bit. Crystallizations aren't 100%, but they're relatively quick and easy. I know this video is going a little long because I'm teaching you each little part of it. All right, and then if you say wanting to recover more of the sulfanilamide from here and also from here, what you can do is rinse. We'll do this. I'm going to rinse this out with some acetone, the inside, to get the leftover sulfanilamide in there. I'm going to combine it with the mother liquor, and we're going to evaporate the mother liquor to see how much solid we have left over. And that solid will be sulfanilamide that didn't crystallize, and also the impurity that didn't crystallize. So we'll examine that as well. Right now, these crystals are drying nicely under vacuum, but I am using water, and it's tap water, and we want to be good to mother here, so we don't want to go too long on this. So I'm going to only go another like 30 seconds or so, and then I'll turn off that tap water. Now I'll turn off the aspirator. I think it's been drying here long enough. Turn off my water. Oh wait, should I just turn off the aspirator right now? Well, it's kind of still under vacuum because filter paper is sealing off those holes. No, let's go. Let's just say it. Do not break vacuum before you turn off the aspirator. Okay, let's do that. So, how am I going to break the vacuum? An easy way to do it is just to take my Buchner funnel off, the top of it off. There it is. I can set that down, and now I can break the vacuum. Good. And then these crystals on the filter paper, they'll dry eventually inside of this, but I think they'll dry much quicker if I put them on a little watch glass. So I'll show you how to do that. We'll just get a watch glass and some tweezers or forceps. All right, so I'm gonna grab my filter paper out of the Buchner funnel top and put it on this watch glass. I'll use the tweezers and just really carefully pull it over. All right, and now that's more, it has more airflow around it, so it'll dry off the ethanol vapors quicker. That's stuck to that. While that's occurring, I'm going to examine the mother liquor, like I said. The way I'm going to do that is I'm going to take a beaker here, this big beaker, because I want to evaporate the mother liquor. And when you want to evaporate things, they evaporate much faster from beakers than they do from Erlenmeyers, like we did our crystallization. So I'm going to get my mother liquor into this beaker, along with any residual crystals and mother liquor in the crystallization flask. And this is an example of, like I said, remember I said pencil is more permanent than pen? My Sharpie got erased a bit. So this is the sulfanilamide crystallization flask. This little white area on the flask, I could write on that with pencil and it won't get erased by ethanol. But okay, we're okay with that. So, and what I want to do is I'm going to try to get all the solid out of this flask, that flask, and anything that's stuck onto here, maybe there too. I'm going to do it by squirting some acetone in there. Now you might ask, oh, you're trying to evaporate the ethanol, but now you have acetone too. That's okay, because both ethanol and acetone are very volatile and they'll both evaporate pretty quickly. So let me go grab a bottle of acetone. Acetone's over here in the fume hood by the waste containers. This one looks pretty good. There's our nitrogen tank again. So the way I'm gonna, before I do any of this though, I wanna get the weight of this beaker because I wanna know how much it weighs for, to then weigh it after the evaporation. See how much solid is left over. So with a big one like this, I could try our normal scale. No, this is definitely not such a good idea, I don't think. It might work, but see, I worry about weighing this on here because if the bottom of the beaker, because it's so large, touches this outer rim, then it's not going to be on the scale. So let's use the top loading balance right here, this guy. So this guy, it's off currently. I'll turn it on. It's interesting too. These scales, this scale and these guys, see how we got them bolted down? They are the thing that is stolen the most from labs. So these scales, they're expensive, but not nearly as expensive as our NMR, our IR, or GCMS in the back, gas chromatography mass spectrometer. But these are the things that are stolen from labs. The reason is people who are drug dealers want to weigh out their like marijuana or crystal meth. So you have to like watch out for your scales, which are maybe like $2,000, $5,000, and you don't have to worry about your $80,000 or $100,000 NMR. They're not valued as much on the street. When I was at UC Davis as a grad student, we had scales stolen from our labs. So whenever you left the lab, like to go to the bathroom, make sure you lock your lab door. Okay, so back to this. I'm gonna write on this before I weigh it. Yeah, let's write on it. So let's go. This is going to be the mother liquor. Okay, so I was good. I labeled it. I got sulfanilamide mother liquor, MFS 22321. So let's bring it over to our scale. It's reading almost 0. It's probably close enough. Let's do it. Okay, so I'll set that on there, and I'm going to record the mass of it empty. Looks like it is 269.23. I'll go with. Okay, let's get all this mother liquor into our pre-weighed beaker. So I'm going to squirt some into the squirt some acetone into the crystallization flask. Let's roll that around. I'm going to add it to my Buchner funnel because I want that to be rinsed too. So I'll do a couple more squirts on this. I think that's looking pretty good. So I feel like I've gotten pretty much all of the sulfanilamide out of the crystallization flask. And now my Buchner funnel, I might give that a little squirt down too. Oops. Okay. And then I could take that, pour that in there, take this apart. Maybe I want to give this one more rinse down. Take that out. And now my filter flask. I'll unclamp it so that, and I'll disconnect the hose too. It's probably more likely to fall over if my hose is attached when I'm unclamping it. Got it. Okay, now I'm going to add this to my same beaker. So I got the mother liquor, some rinse from the other parts of the crystallization in here. Rinse it out with a little more acetone. Okay, I think I am good. I believe the the non-crystallized sulfanilamide is in here, and the impurity acetate-aniline, and it's not too much. Let me look at it from this. I'll show you from the side. Not too much volume. Maybe see if I can tell from the graduations. Maybe about 40 milliliters or so. So we can try to evaporate this quicker. One way you could try to evaporate it quicker is to set it on the hot plate. If you put it on the hot plate, then you have to be very careful. This hot plate's not plugged in, it's not on right now. if I turn this hot plate on and I turn away for a second, what tends to happen is your solvent evaporates quickly, quicker than you expect, and then you have solid on glass that's not being cooled by solvent, and your solid, you come back and it's all burnt up black mess. So I tend not to want to evaporate organic solvents on hot plates. It usually always leads to problems. So instead of doing that, you could also use like a blow dryer. We got here the Conair 1875 cord keeper, high-tech lab equipment. You could blow dry over the top of it, but then you got to stand there and do it. Or you can just let it sit out and do it on its own and have your hands free for other things. That's usually the thing I like to do. In other cases though, if it's something you want quickly, you'd use something called a rotary evaporator. We have a nice couple rotary evaporators here. I'll talk to you about those in later future experiments. But for our purposes right now, we're not in a big rush on this. I'm just gonna set this in the fume hood and let it evaporate there. Since I've rinsed these out with acetone, my Buchner funnel and my crystallization flask, I'm just gonna wash those in the sink now with soap and water because I've gotten, pretty much all the organics out of them. This short stem funnel, I'm not gonna do anything with that. I just used it to pour ethanol through, and ethanol is cleaner than the tap water and the DI water, so this should be actually cleaner from its last use. And maybe I'll just clean my spatula, and my filter flask. So I'm just gonna clean these with soap and water and then rinse them with water to be used again. And then I will come back and I will weigh out my crystals. I think they've been drying long enough. Aren't they nice? They kind of shimmer, huh? Look at that. Kind of like a disco. Disco. Disco.